before I get started, I just want to talk about what we're going to talk about. And I think for a lot of traditional broadcast engineers, talking about video over IP or just this whole change, the internet, everything else, is really out of the comfort zone, frankly. And what I would hope is that, you know, if instead, if a discussion like this gives you a new experience that's educational, then that actually ends up bringing that area more into your comfort zone. And so if I'm talking about some stuff tonight and it starts to get fuzzy or it's out there and whatever, just remember this, okay? I'm trying to help you guys feel comfortable. And if you've, again, got a question, ask. Questions are encouraged. Now, I used to be a scoutmaster, and so I know enough to say that, what was it we used to say? Relevant and appropriate questions are encouraged. So I'm going to ask Rick to be my Vanna here. And when we get a question, you can, yeah. If you prefer, we have chocolate or non-chocolate items there. And for the folks on the phone, you know, if you see me somewhere else, I'll buy you a chocolate. All right, let's get started, shall we? What is a JTNM? Well, you know, you got a JTNM, you got a JTFFMI, you got this thing, that thing. There's so many words floating around right now. It's the Joint Task Force on Networked Media. That's what JTNM stands for. It's jointly sponsored by the European Broadcasting Union, the SMPTE, and the VSF. And I do not mean to talk down to anybody, I want to be sure everybody's got information. Is there anybody who would like to know what the EBU is? Everybody knows. Is there anybody who wants to know more about the VSF? Okay, so the VSF is the Video Services Forum. I'll give you the Cliff Notes version. Back a long time ago, AT&T used to be spelled capital A, capital T, capital T, yes? And then it became little little t after something called divestiture. When the Russians became a serious nuclear threat to the United States, the President of the United States wanted to be sure that he could quickly address the nation if something bad was happening. And so the capital A, capital T company, the phone company, built an entire another network on top. Is another a word? I built another entire network on top of the phone system. And that was the video transport that linked the big three networks to all of their affiliates all over the country. And it existed in buried underground facilities and radiation hardened and all the rest of it, and that's why it existed. There was an entire infrastructure and an entire bunch of people who were trained up on that video equipment who didn't speak telephone, they spoke video. And so if the video guys in New Orleans or San Francisco or wherever were having a convention, there was only so much equipment in, let's say, San Francisco to support the convention. And so there formed kind of an informal group within the phone company of video guys. And the guys in New Orleans or the guys in New York or Chicago or wherever would send extra equipment out to San Francisco for these events, even though it wasn't their equipment. That kind of cadre of specially trained video engineers formed a group, and I cannot remember right now what the name of that group was, but that was the progenitor to the Video Services Forum. Later on, the Video Services Forum was established after divestiture, but the group concentrated primarily on long-haul video transport. And then over time, as we moved from SONET and ATM to IP, all those guys who had all those years of experience in moving video over long distances were the natural people to develop video over IP standards, because basically the whole infrastructure for telco flipped to IP. And so they had no choice but to come up with some way to provide equivalent services over IP, and now, so now we became the Video Services Forum that invented 2022. 2022 SMPTE standards are used inside facilities. They never were intended to be used inside facilities. They were always intended for long-haul video over IP applications. So that's that. So the whole idea of the Joint Task Force on Network Media was to address a question, which really is, what would we do if there was no SDI? What are we going to do? And the question was, and I've been in meetings of hundreds of people, and I've said, how many of you are going to buy an SDI router in the next 2 years? And hands would go up. And I'd say, how many of you are going to buy SDI routers in the next 5 years? And a few hands would go up. And I said, how about 10 years? No hands would go up. And I said, okay, so if it takes, 5 years to kind of develop the standards and then another 5 years to really get a ubiquitous deployment out there, and it's going to be like SDI, let's see, it's about 4:30 in the afternoon. We probably need to start now, right? And so the effort really started looking at what are we going to do in a world where there's no SDI? And that generally is described as what's the goal of the group. It's to help manage the transition from broadcast infrastructures to IT-based packet networks. The focus of the effort is on interoperability. And what's the scope of it? The entire professional media industry and all of its applications. Because if there's no SDI, you can't say I'm only focused on studio, or I'm only focused on long-haul transport, or I'm only focused on news. I mean, we're talking about changing the entire infrastructure of the industry. So it's some fairly heavy lifting. Fortunately, we've got good engagement. We've got 290 participants from 165 organizations, and sponsored by 3 pretty well-known industry organizations, and it's international in scope. So far, so good. So how are we going to do this? Well, real simple, using internet technology. In a nutshell, that's it. Why? Well, because we seek to continue to exist. Frankly, that's it. And it might be said sort of as a joke, but not really. In 10 years from now, are you going to be able to buy purpose-built, specialist, professional media hardware? I don't know. Anybody a little out of their comfort zone yet, especially maybe vendors? It's okay. People in your companies are very, 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 very engaged in continuing to figure out a business. And there is definitely, I believe, a business here, but not the same way. So let's go back to the how. I said sort of flippantly, how are we going to do it? We're going to leverage internet technology. But what is that really? What is internet technology? Some people would argue that the internet is the most powerful, far-reaching invention. Internet technology is the most powerful, far-reaching invention of human beings. And I don't know about that, but I've heard that argument made. We want to leverage the infrastructure. Everybody knows that there's billions of dollars of deployed equipment out there, right? There's, I don't know how many hundreds of thousands, millions of miles of fiber in the ground out there. Routers, switches, servers, right? A lot of money, a lot of infrastructure, right? So part of this is to be able to leverage that infrastructure. Another part of it is to leverage the intellectual resources that are around the internet. What does that mean? What I mean by that is I have said that if we cannot go out and hire a 29-year-old IT professional who's been working in the industry for 10 years. 10 years of experience, a solid, good person. Bring her into the organization, spend a month explaining to her how her area of expertise, her area of responsibility is going to work, and have her be productive, we are doomed. And instead, right now, how long does it take to teach someone who knows nothing about video and SDI and MXF files and all? How long does it take to bring somebody like that in? 30 years? Yeah, right. For them to be productive, I've heard people say 6 months, right? And the problem, by the way, also is that they'll leave. They'll say it's too hard. I'm not going to do that. I'm going to go work for MailChimp, and besides, they have a cool building down here that used to be the old Sears building anyway, right? But those people are smart, 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 smart. And for our industry to survive, we got to figure out how to be relevant to them. I don't think I need to talk about the R&D investment that's going on in the internet generally, but there's billions of dollars being spent in R&D right now, coming up with all sorts of neat stuff that we need to figure out how to leverage in order to do our business better. Software development methodology. Who has a smartphone that has not said that you have 35 things that need to be updated, in the last month? Nobody. Everybody's smartphone says, here's a new app, here's a new upgrade, whatever. I don't know what you're running, Steve, but everybody else, that's because there are new software development methodologies out here. Yeah, okay, never mind. And that's the exception that proves the point. For those of you on the phone, he held up a BlackBerry, so never mind. Anyway, there's continuous development, continuous testing environments. There are entire deployment systems. There's a whole infrastructure out there that allows applications to be rapidly revised, improved, deployed, tested on a continuing basis. And our industry does not generally know about those things. It's part of why things are moving so fast. It may or may not be the most wonderful thing, but I think we really need to learn about it and use it where it makes sense. Sir.
Sorry, we're going to try and use microphones, Keith, so that people streaming it can hear.
So you talk about using a smartphone as an example where the platform is continuously updated, and anybody who has a decent PC, whether it's Windows or Linux or whatever, it's hooked into some sort of central database that is sending you updates. So are you saying that going forward, our video switching equipment is also going to be updated like that? And why shouldn't that strike fear in our hearts? Because we want a stable platform, doesn't change, and maybe once every 6 months. Okay, go ahead and do it. You think we're going to be losing that control, or we just need to accept that it's going to be okay?
No. So I'm going to say a lot of things that probably will be like that. Rick, could you give him his choice of a thing there? The answer to your question is just because you can do this doesn't mean, Rick's used to working at the baseball stadium. Just because you can do it doesn't necessarily mean that you will do it. But the whole process involves a discipline in the code writing that fundamentally changes the way applications are written. And it forces developers to develop module tests that they check in with their code. And the system nightly builds continuously. You see if some developer checked in something and it was bad and it failed. Now, whether you then decide to push a release out, you may decide to push a release out once every 6 months. Whether you as a user decide to accept that release and actually install it, that's a whole nother discussion. But the way that code is being written today by smart people using modern means is something that the industry really needs to pay attention to. It fundamentally changes the way software programmers and software development is done, and we need to be leveraging that. Approach to virtualization and scalability. I've talked to Richard Friedel out at Fox a number of times, and he says, you know, what I would really like to be able to do is when some wacky network guy has got some idea for a new network, I want to be able to just give somebody a credit card, have them swipe the credit card. We bring up this service, and if the thing turns out to be a total disaster, we just shut it down in a few months and we're gone. If it turns out to be something that's viable and it's going to have legs to it, we'll look at investing in a more permanent infrastructure for it. But that virtualization, being able to bring up, scale down things, generally speaking, we can't do that. And when I worked here at Turner, trying to right size the size of the investment for what the network was going to actually generate was a constant pain. Also, something else that the internet does well is it leverages successful patterns, and something that if you haven't heard of already, you probably will start hearing about it. It's the term pattern and anti-pattern. And it's actually very simple. A pattern is something that worked well that you would like to repeat. An anti-pattern is something that never, ever, ever should be done again as long as anybody lives in the organization, right? And there's actually methodologies for capturing successful patterns and also capturing anti-patterns. And also current modeling methods, I'll get into very lightly, something called the Unified Modeling Language, but there are ways to model how you want systems to work, and the internet actually can take you from a model of how things ought to work straight to running code or running applications, and that's something we need to look at.
But I think one of the things that you don't have up there is economy of scale, because what we find and this was from a number of years back, a quote that said the entire amount of money spent in broadcasting, TV, video, and so forth amounts to less than 2% of what is spent on switches alone. So that economy of scale, we go, I know trying to get a E to O to E converter for video was $1,000, and I could get it for data for 200. That economy of scale has just got to be huge for us and take us out of this dedicated equipment to be able to use these as commodities.
Absolutely, and there, thank you, Rick. And you're correct, and so that fundamentally changes actually the SMPTE. It actually changes everything. So how many standards does the SMPTE need to write anymore? How many technical recommendations does the BSF need to come up with anymore compared to just saying how to use stuff from the IT world for our industry so that it really works reliably, right? So it fundamentally changes things, but you're right. So when we were talking about this Joint Task Force for Networked Media, and we started looking at the situation, we started out with the simple question, well, we're going to take out SDI, we're going to put in networks. We went around and collected 167 user stories from industry peers and asked people, if you had no SDI, what would be your requirements for what you would need to do in a facility? So we collected all of these user stories, we synthesized those together into 16 super user stories. We issued a request for technology at IBC in 2013. The idea was that we'd get the responses back and we'd issue a gap analysis between what people wanted to do and what the vendors could do with the technologies that they submitted. Guess what? Great news, no gaps. Right. Yeah, so several people in the responses said they could satisfy absolutely every user requirement that we had, which was an interesting proposition. Whether you accept that or not, actually the bigger question was, how do you get any interoperability with the sort of smorgasbord of technologies that were just dumped in our lap? And the answer was you wouldn't get any at all. So in our second phase, what we're looking to do instead is to create a system reference architecture. And the idea of a reference architecture is that within a business context, you know, on-air playback or whatever it is, you come up with a reference architecture, and that contains principles, patterns, and standards. That reference architecture inform system architectures within a particular company, and then those system architectures actually get translated into implementations. It's kind of like in this data, this National Semiconductors data book, 1978 edition. You can go in here and you can look up all about the semiconductors, but in the back of each listing, there's an example circuit, right, that tells you kind of basically how you would use that. So that's what's going on here. The idea is to create a reference architecture that companies, vendors, whoever can bring in, and potentially, if they use the same principles, patterns, and standards, then we increase interoperability. This is something else about the way people look at the work of the JTNM. You've got people who are business planners or users or system integrators or builders. They might be looking organizationally, operationally, functionally, or at an infrastructure. So you can imagine down at an infrastructure and a particular product, people are building very specific products. Up here is what a business, a Turner, a Fox, a Comcast is doing. The focus of the JTNM work in here is really on the functional work, the infrastructure, and down at the system and product level. All this says is that we hope by IBC to publish our reference architecture version 1.0. So let's talk about recent progress. We published something called the Joint Task Force on Networked Media Minimum Viable System Requirements. And then in the mouse type down here, it says of sample system architecture for live multi-camera studio production. So this is something that we published. And the idea of the minimum viable system group, which was headed up by a guy named Thomas Edwards at Fox, was to tackle an operational scenario of live studio production of a live sports studio like what we've got just across the way here without any SDI. Cameras, mics, studio monitors, everything. And they came up with a list of requirements, and all it was a list of requirements to capture and things that we would need to be able to do over IP networks. But it's interesting. This is what it looks like, very detailed actually. But if you look at the video format resolution, the system shall be capable of carrying video payload of any resolution up to UHD2, video image rate up to field rate of up to 300 hertz, video sample depth 1012 bits, chroma sampling 422, 444, and so on. There's pages of this stuff. But the point is, we're talking about an infrastructure that's basically completely format agnostic. You can download this report online, by the way. But instead of being stuck generally to what's carried on a BNC connector, we're talking about being able to carry basically any kind of video, any kind of audio, all across the same infrastructure, anything. This MVS report, which was essentially a set of requirements, was picked up by the VSF Studio Video over IP group, and they're developing a list of candidate standards to solve the requirements. And they may recommend areas for standardization if no existing standards suffice. So basically, they're picking up the requirements for using video over IP in the studio, very detailed list of requirements, and trying to get an agreement in the industry about what standards to use to address this. There's another effort going on now, which is called Web First. And the purpose of it is to identify the requirements for systems that produce content ranging from linear TV to data-rich, immersive, and/or interactive experiences viewed on many platforms within a single workflow. So this is kind of forward-looking television production, right? So they're looking at live and non-live. They're looking at something that makes data a first-class citizen. And what does that mean? That means typically, if you think about it now, data exists on a network somewhere in a facility, but you've got the video over an SDI cable. So the question is, what would it mean if the data was all and the video were all accessible together? What could you do with that? And to some extent, this effort has been very difficult to think about, because it's kind of like, well, if you could edit using a computer instead of videotape, what would you do differently? Well, if all you have is two BVEs sitting in front of you, it's very hard to think that you could do collaborative editing with a pool of editors, right? So it's kind of tough. But anyway, they want to be able to produce content once, but render many times in many places, render anywhere in the production distribution chain, and that's interesting. So what they're looking at is that the actual show that you would see wouldn't be rendered until it got to Bob's computer here. And what he would see there would be different from what might be rendered on a tablet, which is what might be different from what would be rendered on a large screen. I see some. So if there are some of those, let me talk about that a minute. The creative experience is fundamentally changing. If you are a producer of programming right now, and you're producing content for Bob to watch on this thing, you're forced to make different creative decisions than if you know somebody is going to be viewing that content on a 56-inch OLED display. And those are different from what somebody's going to be, different creative decisions that might be made if it's going to be viewed on a handheld device, right? So the requirement is to be able to incorporate, to create editors that allow you to say how you want that presentation to occur when it shows up here or there or on that big screen back there, but have that actual, those edits, those decisions actually made at the point that it's played out, which is really a different way of thinking about things. But if you think about it, right now we've got all these parallel pipeline production processes to produce all these different things, and part of this is to try and squeeze that together. And so the purpose of this web first exercise is, if we were going to produce this reference architecture, right, that we're thinking is then going to develop system architectures within a Turner or a Fox or a wherever that are then going to be built in the implementations, we want to be sure that we don't build a system that just replaces SDI with Ethernet. Boring. Why would you do that? The only reason you would do that is because you can't buy an SDI router anymore. That's the only reason. Otherwise, you would just buy SDI, right? So you want an infrastructure that's got legs to it. So we're trying to look beyond that. As we look beyond, well, let me just stop. How we doing? I don't mind thumbs down. I really don't. Thumbs up, thinking, boring, not relevant. Thinking, yeah, and that's good. Go ahead. Yeah, a lot of us are, he said, I'm trying to formulate the question. A lot of us are trying to formulate questions around this. Trust me.
About video over IP, but you're talking about changes in workflow or changes in creative production. Can you maybe restate why we should care about that right for this?
Yeah, so the question is, if I can restate it, and if I get it wrong, let me know. Isn't this just about video over IP? And if it's just about video over IP, why do we care about the production aspects of it? So the answer is that the move to IP is an elephant. You know the old story about three blind people look at an elephant, you know, describe an elephant, and they describe it differently depending on what part they're touching, right? So for some people, in fact, I would say for most people right now, especially if those people, their careers are tied to manufacturing of equipment, and this is not a slam, it's just how it is. they are extremely concerned with what happens when there are no BNCs on the back of the piece of equipment and there's an RJ45 or a fiber connector. And I totally get that. And that is the thing that this MVS group was focused on. How do you build this thing when there are no RJ or there are no BNC connectors? That's extremely relevant, and we know there are at least 3 non-interoperable implementations that solve that problem out there right now, right? The thing is, if we don't leverage the internet, if we don't leverage internet technology, and I specifically say that different from leveraging the internet, and I'll get to that in a minute, how those are different, because I really don't care that much about the internet, except it's just another antenna, right? And when Ted worked here, and I was reporting to Ted, the whole deal was monetize content. The internet is just another antenna. If you can get money off of that antenna, go for it, right? So I really don't care about that. But leveraging internet technology is the only thing that is going to keep us relevant compared to people like Netflix, Hulu, YouTube, all those, and Google, who are building their infrastructures on what they developed initially, which is internet technology. And if we don't move to that, we will be roadkill. It becomes very philosophical for me, but I'll just summarize it briefly and tell you the only edge we have, the only edge we have is the storytellers. And if we don't make enough money to keep the storytellers, we're in trouble, right? So we need to remain flexible enough and relevant enough that we can get content economically efficiently on that, on this, on that, and this discussion with those optics is all about leveraging internet technology, right? So that's different from a very important, but frankly fairly short-term problem of what do we do when a truck comes along and wipes all the BNCs off the back of the chassis? Please. Absolutely, yes.
So, I mean, how do you manage what people have as far as devices and being able to take that information and render it to certain standards?
So the short answer to your question is you leverage internet technology because that's what they do now. And you can real-time edit 1080p 60 in an HTML5 web browser on, I've got a MacBook, up top of the line MacBook Pro right there, and you can edit full resolution, high quality video and audio in a web browser with no special software whatsoever beyond what's pulled down in the web app. So that's a whole nother thing, and that problem, there are billions of dollars being spent on the control and business process logic behind that also. So these are all very relevant questions and important questions. And were it 5 years ago, I would say, yeah, that's great, but how are you going to deal with rights management? Well, now I can tell you it's beyond geofencing. There's all kinds of technologies out there, some of which companies like Google and Netflix are inventing to deal with those very important questions. So you're good. Go ahead.
Brad, I have a question for you.
You already had your candy.
Oh, that's okay. We'll do this as a freebie. Yeah, a number of years ago, a company called Viz came out with a concept of putting the graphics onto your cell phone, and they just came out with a little app, and it was literally rendered on your phone. They send out the information describing the scene, which is how their stuff works, and it was rendered on your phone. And I suspect that's a little bit of what you're referring to, or kind of what you're referring to here.
Yes, sort of. The HTML, the difference is that that now you can use standard calls, API calls to a widely deployed browser, the HTML5, in order to do this stuff, where then you couldn't. And the capabilities are just tremendous.
Well, I fully believe they were ahead of the curve. They were, I don't know where that product ever went, but HTML5 and the new standards that are coming out is just going to make that kind of thing so much easier.
That's correct. So let's get to some emerging concepts that are there are many different threads here. And so I was glad to see, and I still see, like, thinking, I'm very glad to see that, because all we're able to do is think and talk collectively about this and try and work our way through this. So I'm here today to tell you about some important people. These are not all of the people, but there are some important people working on some fundamental concepts, as fundamental as sync it was for analog video, or how color burst would work. All right, pioneering work. As we've worked through the JTNM work, it really has been a discovery. And it's not that we knew how we were going to do this video over IP stuff inside a facility or leverage the internet when we started this. We didn't even know how we were going to come at the problem, to be honest with you. But over time, some things have emerged. We've got a group that's working on key patterns for interoperability, chaired by a guy named Chuck Meyer. And within that, we've identified some critical things that I'm going to talk more about. One of them is timing, by Thomas Edwards at Fox. Identity, Dr. Richard Cartwright. Capability and discovery, Steve Posick and Peter Brightwell have done some great work there. And also concept of flows and grains. I'm going to talk about these things, and as I talk through these things, I hope you'll start to see how some of this comes together to address what the future of television is likely going to be. Oh, look what happened to that graphic up there. That's really amazing. Wingdings, I recognize that font. Well, doesn't matter. Paul Briscoe is another really smart guy. And the great thing working in this industry is there's a lot of smart guys. It's really neat. Anyway, there's something called IEEE 1588, and this gets to how are we going to do timing in a network? Yes? So there is a SMPTE standard that talks about a profile for precision time protocol, or PTP, and the way it works basically is that if you've got this PTP clock running, then you can have different video frame rates that are synced up at a particular point. And that point is called an epoch. I hear it pronounced different ways. But anyway, the point is, once you turn this belt on, these two things are only going to line up every now and again, right? So, and there's all kinds of instances where this happens in television frame rates, thanks to NTSC, 2997, and it's a shame. But anyway, but the thing about it is, once you do hit the button on here, and then if you freeze it later, and you know how far this thing has gone, you can actually calculate where these two different clocks would be. It's all locked together. And the really cool thing about it is that if these motors are synced up to GPSs, then this timing machine can be distributed worldwide with different video applications running at all kinds of other wacky rates. It really doesn't matter. So long as there's a standard that describes how this is all linked together, you can always calculate any of these different clocks based on this precision time protocol, the PTP. Yes, sir. NTP. That's right. That's right. That's exactly right. So if you didn't hear it, the kind of the predecessor incoming of PTP is NTP, Network Time Protocol, and they needed a more accurate one that came up with PTP. Yes, sir. Yeah, well, right. So GPS will, the short answer is yes. Let me just, because I don't want to do that takes a whole night. So that's one thing, time, right? So to come back to this slide, remember, these are key areas where if implementers choose a similar approach for all of these topics here, there's a likelihood that we're going to be able to build interoperable systems, which we can do great with SDI right now. IP, not so much right now, like at all. So that's the solution on the table right now for timing. And it looks pretty good, looks pretty solid. I would be very surprised if in the future we're not doing something that's based on the SMPTE profile of PTP. Identity. Dr. Richard Cartwright. Man, he and I have had some interesting conversations. I could talk all night about identity. I really could. So when you talk about something, typically you want to get the something. But historically, I wish I had a videotape. I should have brought a videotape. We talk about, historically, we have talked about the thing in your hand, right? So if you have an identifier, yeah, off he goes. So if you have an identifier, almost always that identifier referred to a thing that you held in your hand, but you didn't want that physical thing in your hand. You wanted the representation of what was on it. Nothing there? Okay, Turner's officially gone tapeless. Oh, no, here we go. All right. Yeah, okay. That's fine. All right. But what you really want is Foster's Home for Imaginary Friends, episode 4, Busted. Ah, okay. Right? But the identifiers, we've always, traditionally, we've tied to this physical thing, right? We don't care. Not only do we not care, it's actually a hindrance to be referring to a physical thing. Uh-oh. Amber alert. Okay, that's fine. I didn't see any, yeah, I didn't see a tornado. It does stop. Okay, so I had here, you know, the title of this is Identity, and I had an alternate title, which is Identity, Why Do We Care? Right? So here's why we care. This was then. This is now, right? So if this is in the cloud, I know people draw the little thing. This is the way I look at the cloud. But, you know, if this is in the cloud, somebody else's, we want to get at content that could be stored anywhere, right? Anywhere on the planet. And without identity, we can't make any money. It's as simple as that. Without identity, we are out of business. So here's the draft Joint Task Force on Networked Media Identity Model. And I thought I would just try this on this group for size and see what you guys think. The JTNM identity model is expressed in the following 3 rules. 1. Internet-style unique resource identifiers shall be used to identify the resources used in networked media, where every instance of a class in the JTNM models is an addressable resource with at least one identity. Every resource must have an ID. So except for the Amber Alert things, just bear that in mind. Everything must have an identity. Every resource, that's going to be an important word. Second of all, identity is a logical indirection that shall be resolvable to provide access to a representation of a resource as per RESTful principles, but hiding form, location, and function. Conceptually, physical resources are not addressed directly. All right, I know it's hard to focus, but this is really, I think this is some of the most important stuff there is. Identity is a logical indirection that shall be resolvable to provide access to a representation of a resource. Hiding form, location, and function. An ID gets you that episode without you having to know or care where it is, that it's on a VHS tape or that it, whatever. An indirection, if this thing has an ID 2, number 2, you should be able to get this content here or here and not care. That's a redirection. I want 2. A resolver then says, well, I've got 2 here or I've got 2 here. I'll give him 2 from this. Everybody okay? This has to have an ID. This has to have an ID. The episode, Foster's Home for Imaginary Friends, has to have an ID that does not tie to this physical thing. That's handled in a resolver that sits here. I call Rick. I say, Rick, I want 2. Rick resolves my request for 2 to this. Good? Yes? Okay. Relationships between resources shall be expressed using identifiers and only through identifiers. In other words, the only way that I know that this is Foster's Home for Imaginary Friends is not from this tape label, ever anymore. It's through the system that can resolve it to that. And importantly, changes shall be managed as a kind of relationship whereby a reference to the current version of a resource is a pointer to an immutable object that is the latest revision. More on that in a moment. I love identity.
So what do you do about things that have not been ingested yet?
Do you know they exist?
Sure.
Then they're an entity. You give them an ID, they exist.
Can't access them.
No, it's okay. If for some reason you need to know that they exist, you give it an identity, and from then on you refer to it that way. For example, in a contract, you know that you're going to get this at some point in the future. You can give that an ID that's just a placeholder that's linked to some physical content later on. Jack.
I'm working in my head the difference between the fact that we have the identifier and then somehow there will have to be some, I'll call it a database that lets me link from identifier to the actual resource itself.
Yes, there will.
I'm just trying to show and give you your next topic.
Yes.
Before you go on, isn't there, because it says that it's actually looking at any latest revision, and I'm looking for 2, and it's going to give me the latest revision. What if I wanted to see the revision before that?
Wait, I have a slide for that.
Oh, okay.
I have a slide for that. Wait. Okay. So, yeah, we have an app for that. So in terms of identifiers, we said here that we're going to use IETF RF URIs, right? Well, just briefly, uniform resource identifiers. Here's a couple of them. You know a URL, right? In fact, if you want the URL for the Wikipedia entry for uniform resource locators, well, there it is, right? Guess what? It's a resource locator. It actually points to a thing. A URN, universal resource name, earn ISBN 01, blah, blah, blah. That's an ISBN code for the last unicorn book, right? So both of those URLs, there's an example, URNs, there's another example, are examples of uniform resource identifiers. They're used everywhere. That's what we need to use in the industry. It would really be not intelligent of us as an industry to come up with our own identifying scheme, which is one of the reasons that I keep saying we need to be doing our stuff that leverages the internet. Every software developer on the planet knows how to use this stuff. Immutability, that term was in there. Once you make something, you cannot change it, kind of to your point. But wait, we love change. Or we hate change, but we have to deal with producers who love change. I mean, take your pick, right? But we love change. So how do you deal with once you make it, you can never, 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 never change it? Well, the answer is you just have to live with it. Why? Well, because it ensures transactional integrity. It allows parallel processing over shared resources. It allows you to operate at a global scale. And resolvers like Rick make it work. So without immutability, you cannot do many, many, many things that you do with computers every day. So it's just the cost of doing business. Ensures transactional integrity. What if you're dealing with your bank account and as you go in and you start some transaction, something else in the bank is happening somewhere else? If you don't have a unique identifier for the process that you were engaged in at that time, very weird things may happen to your bank account. Or if you start parallel processes over a number of different processors, as those different pieces of computation get done, the unique immutable objects that they're working on don't change underneath. You don't have, let's see if I can put this another way. If you had two editors that are working right on the same content, and one of them, as this system was getting ready to make an edit, over here it deleted the piece of video that this system was just getting ready to edit, things would fall apart, right? So the way you deal with that is that you never change this. When this thing makes an edit, it creates a new version over here. It doesn't mess with this, right? So you said, how do I get to go back? Which you can do, by the way, in the Google Docs stuff now. You know, you can go back in time and you can go back in all kinds of stuff, right? The answer is right here. Resources that change over time are given a two-part identity, a resource name and a revision number. For example, if you wanted to implement this using a URL scheme, then you would say, go to the JTFM RA reference architecture report. And you would give that to Rick, and Rick behind the scenes would actually point you to the RA report, that's the resource name, revision 3, right? Which is hidden from you. All you know is you're getting the RA report. If I go in and rev that, I change the revision number to rev 4. We can always go back to rev 3. You never see this. All you see is you requested the report. And an awful lot of that goes on behind the scenes the way the internet works today. This is a very common way to handle that, two-part identity and immutability. So I hope that slide answered your question. So hold on. Okay, go ahead.
I do understand about seeing the revisions.
Yep.
But at some point, if I'm looking at RA report and you're giving me 3 and soon to be updated to 4, but I wanted to see the original report before the revisions.
Yes.
I can't do it.
Well, what if I gave you a button on the web browser that said, see previous revisions? And then it showed these, and in a UI, it would say, here's the current version, here's the last version as of September 3rd, here's the last version as of June 9th, here's the last version of whatever. Remember, this is under the covers, so how this is shown to you can be in any way. So if I'm not, I can tell I'm not making sense yet. So
it makes sense, because now you're adding something more to the URL that I'm actually looking at that says, oh, did you want to back up? Oh, did you want to go forward? Oh, do you want to go sideways?
Sure.
I get that.
Sure, and in fact, an awful lot of this happens on the internet. If you pay attention to what happens to the address of your web browser after you type it in and hit enter, an awful lot of stuff is rewritten to go to Rev 3 unless we changed, we release a new RA report, in which case now in the resolver, I write Rick an email and I say, hey, Rick, anytime you get a request for RA report, don't send them to Rev 3 anymore, send them to Rev 4. He says, okay. He makes a note of that. You come in and ask Rick, hey, Rick, I want the RA report. And he says, no problem, here it is. And he gives you Rev 4. You don't even know there was a Rev 3 there before. Unless you said, hold on, I want to pick on my web page, I want to pick show me previous versions, in which case we could roll out any of that we wanted.
I actually was putting that together with the example of the tape itself, number 2.
Yes.
And if there is a revision on number 2, it could be Rev 3, Rev 4, what have you. But if I wanted to see the original version, I mean, you've given me the tools to do it. I get that, but that was where I was trying to put my head around.
And very good, and that's exactly how that one way how that could work. All right. Resources. Everything is a resource. So what does that mean? No, bad idea. Do not throw the banana pudding. It will be my sign that I'm losing the crowd. Think about this. If a resource has an identifier and you can discover the capabilities of the resource somehow, then you can consume that resource, whether it's a video stream, a transcoder, a person, a live remote van, a camera, a long-haul transport path across the Atlantic, whatever it is, yes. Anything, any concept even, right? So this identifier is really key.
If I can, Brad, can I ask a question about that? So that implies, or if I'm understanding it correctly, that I have a facility and I've got 600 DAs and paths, and each one of them is going to have, yes, you're shaking your head. For those who are streaming this, he's shaking his head. Yes, that each one of them is going to have this unique identifier.
Right.
It comes down to almost every wire, wouldn't it?
Sure, why not?
It's a lot of numbers.
They're free. That's the thing. Well, yeah, maybe. Databases can handle billions of transactions or billions of records. They can handle millions of transactions a second. I mean, back to, I think, your point earlier, leveraging internet technology just gets you that answer. I can download databases, free databases that have that capability. So, capability. I could talk about capability for days. So, imagine, up here at the business process layer, Ted used to say, monetize content. That's it. That's all I want to do. So we have applications here, media applications that allow us to monetize content, whether that's news, sports, you name it. We have media applications that do that. Down here, we have data centers, internet type technologies. We have video and audio specific hardware. Down here, we have networks, all of this stuff, right? Think about the concept. You were talking about hundreds of DAs, thousands of tens of video servers or whatever, editor platform, whatever they might be, right? So what if for any particular media application, there was a list of things that you had to have in order to be able to do that application? And those things could be offered up in a platform as services to satisfy whatever capabilities were required in order to be able to do that sports cast or whatever. We're talking about a dynamic plant here. So this is kind of a shift in gears, but Steve's nodding his head. He's kind of, okay, right? So instead of having purpose-built equipment that's assigned to do a specific thing, or a transcoder that's always lined up in the same workflow all the time, no matter what, you've got a transcoder out here that's down in this industry-specific hardware. And if it has an identity, and it can announce that it has the capability to transcode from 1080p 60 to a format that can be used on that smartphone sitting on that desk right there, and it's just standing down here saying, I've got this capability, I'm here, I can do this. And you've got a media application from up above that says, I need the capability to transcode from 1080p 60 to that smartphone right there through a I want to come up with the right word here, control plane that's not shown on this diagram. You can grab that resource with that identity and employ it in that workflow. Yes? If we need a DA, we can grab the DA. Whatever it is, we can grab it through the concept of I need these capabilities and I have this capability. It's kind of like a speed dating thing for video facilities or whatever.
So the challenges, and just from what I'm gathering in the first couple minutes here, the challenges to being able to pull this off are immense. First off, we have to have some way of making sure we have the unique metadata identifier.
Turn around and look at Steve.
Hi, Steve. No, we don't need a unique one?
No, the challenges are not immense. In
Okay.
fact, it's already being done. In fact, 10-year-old technology? Yeah, this is 10 years old. Yeah.
So, but you need to have it unique.
In our industry, there are all kinds of challenges, but they're not technical.
Then for each piece of equipment, it has to have some way of having, I don't know, compared to an XML or a MXF type tags would say, this is what I can do.
Yes.
And as our industry develops, as progress occurs, those tags have to be fluid.
Yes.
Because new tags will occur. Okay, I call that a
yes,
mess, but
yes.
that's okay.
Exactly. Exactly. And now, a computer science course. There's this thing called Unified Modeling Language. And in UML, you can represent anything, evidently. But imagine that you have a service, and this service is a transcoder. And the transcoder offers the service to translate from 1080p 60 to some format that smartphone likes. It probably likes 1080p 60, but we won't go there right now. That's represented in UML by a fist. An application that consumes a service that's being offered up shows it as like an open hand covering the fist. Yes? So here we have a service which is being offered up in an application that is using that. Oh, look, here's the application, here's the service. 10-year-old technology, as Steve was just saying. Services and applications have been modeled in UML for a long time. So, one of the things that the Joint Task Force on Networked Media is doing is talking to the computer people in your organizations who will look at this diagram and say, oh God, I feel so much better looking at this than a SMPTE document on MXF. Not in a bad way, just they live and breathe this stuff all day long. So one of the things that we're doing in the JTNM is we're developing a set of models that talk about things like capability. So look, oops, here's a service. Could be a transcoder. Actually, here's a device which is can deploy a service. It's a transcoder. Deploys a service at an endpoint through a capability interface. And that's how that transcoder would be able to do that. Actually, here, it's a video device which has a service with an endpoint, which has a capability interface, which is exposing, for example, keying or layering capability. Yes, anything can be modeled like that. And look, the capability interface with keying and layering is described by a capability with an ID. Just what you were saying, Jack, where I've got this capability to do keying or layering. Yes? And with different configurable parameters and values and so on. The thing about this model, the power of this model for people who speak it, is that if you get two developers in two different rooms and you give them a more fleshed out model like this and you tell them, build me interfaces for your keyer and your layering device, they will interoperate more easily than if you gave them a Word document. So we're speaking to the guys with this as well. Let's talk about grains and flows for a minute, because, I don't know, some people are talking about grains and flows. BBC R&D has been working on this IP Studio project, and one of the things about that, you probably know about that, right, Steve? You want to talk about this? No, okay. That was a different project. Anyway, I just wanted to throw some terms out there just so that you can think about it. A grain is a unit of a single type of essence or data, i.e. a video frame, but it could be anything, an audio sample, a piece of closed captioning, whatever it is, a snippet of stuff. A flow is a sequence of grains available for transport from a sender to a receiver. So if you're going to flow video out of a camera into a server in SDI, you hook up the cable from the camera to the server, and you hit record, and there you go. The flow is flowing, right? Well, see, the internet was developed to solve this problem called the smoking hole. And the smoking hole was that the Department of Defense really would like to launch the nukes, but the Russians already managed to turn Chicago into a smoking hole, and that was a core transport point for communications out to Idaho. And so actually the internet developed by DARPA is self-healing. It would send packets through Atlanta to get to Idaho if it needed to, or whatever, without any intelligence from anywhere else. So the thing about that is that networks will do that without there being a smoking hole. So if you've got a camera with an IP connector on the back of it, and you plug that into a switch, and that plugs into another switch, and there's a switch over here, and these two switches are cross-connected, and then over here there's a recorder. All the camera knows is that it's launching a packet, and then it's launching the next packet, and then it needs to go to over there, that IP address over there. And how it goes is indeterminate. In fact, by design on the computer networks, if something happens to this switch over here, it's going to take a different route. Well, if it arrives on a different route, and one route is from New York to Atlanta, and the other route is from New York to Chicago to LA to Atlanta, it's possible that you're going to get out of order packets, right? Some packets could get from New York to Atlanta before other packets get out to LA and back over, right? But you don't necessarily know that. So the concept of a flow starts to give us a handle to understand that this packet and the one that was launched out after that are actually associated with each other. because the internet was designed so that packets actually, once they're launched onto the network, they didn't have any association with each other, right? So this is a video flow out of a camera. A source is a logical creator of a flow. Destinations may have, devices may have several sources, like a server might have a video source and an audio source. And packages or bundles or groupings of sources, flows, and forget the rest of it. So you might have a bundle which consists of a video flow and 2 audio flows, or 4 audio flows. And as it goes through the network into a device, some audio flows might get stripped off, and other audio flows might get put on it and then squirted back out, right? So that's the concept of a bundle, is that you've got a feed that used to be languaged in English, and now it's languaged in Spanish, and that happens along the network. So these are the way that you would deal with that, is through packages and flows. I don't know, it's getting later. I would just say that through time, a grain can be synced with time, a source ID for where it came from, a flow that says, I'm part of a video flow or whatever. These grains can get loaded into RTP headers, and then from there, basically those RTP headers can get loaded onto Ethernet. And whatever we come up with for video over IP in this new world is likely to involve this process of grains or samples going into RTP for right now, going into IP and Ethernet. The beauty of this is that later, if something replaces IP, this will still work. Do we have a question?
We have a question from streaming audience.
Fine.
So if we go back to the concept, and Dick, I hope I paraphrase this correctly, Dick Barron.
Hey, Dick.
If we talk about the concept of networks, the one-to-many, or not only the one-to-many, but one-to-many different formats, resolutions, etc. Do we have the concept of that we have with multicast, where the one source has can go to many different and be copied many places, or is it this stream, this bundle, from source to a point?
Okay. So,
and Dick, tell me if I got that wrong.
So, as I understand it, it's basically, is this point-to-point, or are there point-to-multipoint mechanisms available, since basically that's what we're doing in broadcast? And I guess there's the short answer, and there's the 4-hour long version. We don't have time for the 4-hour version. Oh yeah, teleport that piece of chocolate to, sorry Dick, I'll eat the chocolate for you. Yes, point-to-multipoint. And so the short answer is, if people just throw out that multicast solves all your problems, then someone else will say, well, not all routers support multicast, and so it doesn't actually get you point-to-multipoint. And then other people who are in the multipoint religion will say, well, actually, if you just run current software on your routers, you cretin, you will get multi-point support. And then we'll point out, well, are you talking about IGMP version 2 or IGMP version 3? And then, so rather than disappear down that rat hole, all I'll say is you can use multi-point, use IGMP type technologies if you wanted to do broadcast type stuff. Also watch the space on software defined networks, SDN. A lot of distribution is happening around that. But I would also point out that whilst there are all these people who are saying that you can't do point-to-point efficiently, I would just say that all these smartphones I see sitting on these tables here in this room, they all have single IP, unique IP addresses, and Hulu and YouTube and Netflix and HBO Go and CNN Go and Fox, and they seem to be able to distribute on it, so it might be a non-problem. I don't know. Oh, I was going to get rid of this build. Let me just go through this. La, 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 la. The other thing that's important is this, the idea of capabilities being registered somewhere. How does that work? So if I'm a transcoder and I can transcode 1080p 60 to something that smartphone right there would like to ingest, well, how does anyone find out I can do that? How does all that work? And so what I would say is that, in short, if you have a device, it can push a capability up to a registry, and then that registry, using something called the Raft consensus algorithm, can populate other registries in other places so that there's not one registry to rule them all that then falls over and the whole thing just collapses. This is a little lightweight right now in terms of our thinking it through, specifically on what is this REST API that everybody knows about, so I can describe all my capabilities so that anybody can understand what those capabilities are. More work required. But I did just want to point this out because this is an interesting thing. Man, when I was here at Turner, we spent millions of dollars working in software development on a large software database-centric application, which failed. But I think other organizations have had similar experiences. But we spent an awful lot of time talking about consistency, database consistency, and how do you make sure across this massive database that all these people are flogging away at all over the country is always just perfect. And then somebody came up with a concept which is called eventually consistent databases. And it's like, man, why didn't I think of that? It's just like thinking about real time, which is the other thing about network-based IP applications, which is everybody says, how is it going to support real time? Okay, yeah, you can move a file from here to there, but how are you going to be able to deal with real time over the network? And the answer to that is, think carefully and tell me exactly how many applications you have that things have to happen within a frame. And it turns out that there's a very, 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 very narrow set of applications where that needs to happen. Almost everywhere else in our business, it doesn't matter. It could be delayed days. Rick said this a number of times in meetings I've been in. Anyway, but it's just interesting that there are algorithms that even if you make an entry in here and these other databases actually aren't rationalized right now, you know, if they get rationalized at some point, it's okay. The world will not stop spinning. And it works out really well. And by the way, the Raft consensus algorithm is interesting. It comes from I think a 1900s paper about if you have a life raft, how do you elect, what's the most efficient way to elect a leader on the life raft? Anyway, pretty cool. So that's how that part of it will work. Ooh, still building. Go away. There we go. So we're done almost. To Steve's point, this is not rocket science. Almost everything I've talked about here is not rocket science. Yeah, exactly. It's just rocket science to us, which is kind of the challenging part of this, right? Almost all of this is very much steeped in well-proven, solid patterns in computer science that 29-year-old I told you about would walk in and look at and go, yeah, I've already worked with that. Yeah, I know how to do that. And she would be able to take that platform I was talking about and write new applications that were doing stuff on the next thing that came in the door using these techniques that I'm talking about here. So the challenge that we face as an industry is to not do the same old thing. And the same old thing is to figure out a way to create silos that drive people in a particular direction and don't leverage internet technology. And if we do that, we're not going to be around as an industry. We're not going to be here. So, contact info. There is an email up there if you have questions about the JTNM effort, or you want to talk to me, or you have recommendations on which 25 slides I could pull out of this to make shorter next time, send me a note. And otherwise, are there any other questions? Yes, sir.
I go back just one step. Am I
Yeah.
thinking about it wrong? Live sports. It's a short question.
That's all right.
Am I just thinking about it wrong? Is live sports, live news, two-way interviews, multi-city interviews, is that not real time? Is this?
No, absolutely it is.
So the latency that would be involved in all the processing and all the routing and everything else, it doesn't have to be frame accurate, but it's got to be pretty close.
Well,
Or what am I missing?
so yeah, actually here, we got the guy to tell you about this right here.
Keep in mind, you're already
I've heard
doing it
this.
that way. You know, you've got your compression on satellite. A lot of it's already going. Parts of it are going IP. You have your fiber networks like level 3 and stuff like that, which is doing what's it called again? It's doing basically it's IP. I can't remember the name of the format they're using. So to a large extent, that stuff already is some format of switch packet digital. If you're doing for news gathering, where you're doing so much of it now is bonded, bonded LTE for news gathering. That's about as IP as you can get.
Right, but I think that you make a good point, which is what about the latencies, right? And I think that there's several levers we've got to deal with for that, all right? So there have been techniques that have been around for a long time that members of the Video Services Forum in the service providers group, level 3, and the Belcore companies, all that, have been using for a long time to provide nailed up paths across a network from a facility to another facility, right? And the reason you want a nailed up path is because you want, even if maybe you've got long latency, you want predictable latency, right? I mean, the worst thing you can have, and I just came, so did Rick, from AT&T Labs out in Austin. One of the things they were talking about is varying latency. So you can imagine trying to do a live interview between somebody where the latency is changing back and forth, right? And so you get used to, okay, we're over a 200 millisecond link. It's going to take a little while, and then it speeds up, and you think, oh, we're okay, and then, So predictable latency, predictable paths, though, also give you the ability to send packets through particular paths that are provisioned for professional networks, right? So they've got automatic failover. There's something called SMPTE 2022-7, which is hitless switching protection. So that nailed up pathing gives you that. To go down a path that's then covered by hitless switching if one side fails or another. And then there's also up and coming SDN, software defined networking, which, remember, the whole idea of the DARPA project was to solve the smoking hole problem, right? Where it doesn't matter what happens in the network will figure it out. Well, you're talking about a situation where you don't want the network to figure it out, actually. Actually, you want to tell the network from here to there, this is how you're going to go. And software-defined networking is another way to get that same kind of deterministic flow through the network. But something else to do, and I know Rick has looked at this a lot, is also to think about where the sources of delay come from in your viewing experience. A lot of that may not be associated with transport. It may actually be associated with coding, decoding, display lag.
Yeah, it's usually not the transport. It's usually the coding. And, of course, I'll move away from Bob here before I start saying this one. But, we've seen a lot of that, whether it was in Baltimore or whether it was the situation in Nepal, where, you had the anchor saying, well, the situation looks a lot better there in Baltimore tonight. Don't you think so, Fred? And he's sitting there going. Oh, yes, it does look a lot better here tonight, you know,
Right.
because the latency the LTE, because the data rate's going down, the compression is taking longer and longer and longer. In some cases, it's got some serious latency to it.
And Rick, as you talked about, you did the presentation on bringing back Gulf
Yeah.
from Scotland, putting in a 2-second delay
Yeah.
to buffer and take care of it. And that's another, that's
Right.
where we are right now,
And we
using internet and so forth, because we don't know what's going to happen.
Yeah, yes, and no. Well, keep in mind the internet. If you're talking the internet, the transport, usually at most you might have 200 milliseconds of latency on the transport. That's considered a long transport time across the internet. It's the compression and the codecs and the variable bitrate codecs that cause most of the latency.
But don't you also experience that the internet, as you said, oh, I'm going to change this route because I can do load balancing and so forth. So instead of coming from Scotland to New York to Atlanta, I'm going to go from Scotland to China to Russia to.
But the beauty of it is it's all terrestrial. For those of us used to dealing with satellites, we don't have that extra 44,000 miles of travel.
Yeah, okay.
And so even terrestrially, most of that isn't even the routing, it's the number of switches you go through. It's that the several microseconds or milliseconds that it lives in the switch between the time it comes in and it goes out. It's actually not the transport over glass, because you know the speed, even at 95% the speed of light, it travels fast through glass. It's the number of switches it hits.
Question in the back here. That's a great question. So the question is, all these networks, are these private networks or public networks? So
Yes.
maybe you can give me in what frame of reference, and then we can answer the question.
Here you
go. Once
Yeah.
everybody starts doing that, we've already seen where you have internet delivered media. Sure. The boxing match the other night or whatever, it crashes the network. You can't, there's not enough bandwidth.
Right.
And so now you have people like Netflix that do something a little bit different where they're putting in servers in all the cable networks.
Right.
So it alleviates that. But so what happens when all this turns IP and it all goes down the same pipe?
Well, it won't. And for exactly the reason, I'll let you keep that just in case you have any comment, but for exactly the reason that you talked about. And this actually builds on a question that you were talking about earlier. You know, for content that's going to be delivered to a number of people in an area, they're going to push that content let's see if I can say this formulaically. They're going to push that content out as far as they can while it still makes economic sense before the number of times that gets split becomes so low it's not economically feasible to push it farther down. But there's all kinds of, again, computer science around CDNs that has to do with how that works. But I think we all, and believe me, I've been in this industry a long time too, and you know, it's just it's a difficult thing to shift your thinking from it's just always got to work, right? That's in my DNA from long time ago, right? But the fact is that the business is going to choose how much of the time it has to work. And there may be times that stuff that we deliver doesn't make it anymore, you know? But I think it's just going to be a business decision, and that's where this stuff is going to be driven. It's going to be a business decision ultimately, because from an engineering standpoint, can we engineer stuff so that it will always be up? Well, as much as we can guarantee that a twin-X hybrid RF link from Chicago to Albuquerque, New Mexico is still up, and a clamp tube didn't go bad, and a clamping amplifier in some AT&T hut somewhere, right? Those circuits failed too. But I mean, we have the sorts of levers to make things work really well. How much is that worth? And I think that's something that's important too. I was in I think it was this very building, talking with a very irate network head for a Latin America service. And we were telling her, no, you will not get a certain capability. And that was a capability that TNT had, TBS had, Cartoon Network had, and she did not have enough money. Her network did not make enough money for Scott Sassa, who was the money man who sat up in the mansion, to say, I'm going to give you this kind of infrastructure. And I got the joy of sitting with her and my boss to tell her we weren't going to give it to her. The problem is that I was locked into one flavor of infrastructure, right? I only had one price to give her. And the difference now is that I can go to Rick or, transport people or facility people, and I can say, look, this is how much money Charlotte has. So what can we do? And now, what I could do for Charlotte on a platform like that is going to come at a tremendously lower price point than what I had to tell her she had to come up with those years ago in an office over there somewhere.
But Brad, Bill's question points to something else. Where if I'm inside this facility, I'm using IP-based, I have a trunk line between this building and the next building over, and I picked up X number of 1.5 gigabit HD signals. All of a sudden, X plus 1 wants to come online, which is going to overload it. Have you built in the structure to say you're going to overload that resource, pick another path?
Sure. That absolutely concretely exists because Wall Street, the Department of Defense, hospital, surgery, suites, all kinds of places have to work. And whether I use MAC addressing per ports on switches, or whether I use the capabilities built into software-defined networks to lock down a network or whatever, those capabilities absolutely exist. It's a field called traffic and network engineering and traffic engineering. It's a whole discipline. So do we necessarily know how to do that well? Maybe not. But can we hire people from other industries who know how to do that? Absolutely. And it's not a technology that has to be invented, or speaking frankly, that we should invent. We should not invent it. We should be able to hire that 29-year-old traffic engineering expert and tell her, I don't want Jack to walk into my lab with that laptop and plug it into the back of this top of rack switch and bring this thing down. And she'll say, okay, and she'll be back in 10 minutes and say, that's done, what next? And I'm serious. If we don't come up with some specialized standard just for us, she can do that. Right? Other questions, lingering thoughts?
Are there any questions from the streaming audience?
Oh, they've all passed out. Yeah, oh, couple.
You are to be congratulated for covering such a wide range of topics in such a short period of time, Brad. Thank you.
You might need to hold the mic a little closer for the phone.
I have an accent, apparently. It scares
No,
me.
we all have accents, I think is what I hear.
Look, I mean, really what you are to be applauded for doing such a great job of such a wide topic in such a short period of time. What you're really talking about is helping smooth the adoption and interoperability. I would like to suggest and posit and make the statement, look, this transition is happening. It is inevitable, and before you blink, it will have happened. That, we should not delude ourselves that the economics that are driving the business to allow the content to flow and to allow the storytellers to tell the stories they want to tell. The economics are such that we have to adopt internet technology and thinking. I think that's a given. The most amusing conference I ever attended recently involved the expression from a post house owner who stated, standards are for the slow and the weak.
Jeez.
And I've never
Okay.
seen Pete Putman jump up so quickly before. But what the guy was saying is, look, I can sling a virtual post house together right now. And the reason I'm nodding my head, say this stuff is not hard, is because people are doing it. People are virtualizing the edit process. People are standing up virtualized storage. People are standing up databases. There is no standard for the capturing of metadata for cameras. The quote from this gentleman was, I'll just run Google search on it and get the information I need out of it. All of the tools are in existence. What they are is painfully inoperable. That's where, that's where the work of standardization and interoperability gets confused. It's the ability to share the stuff and use the stories that you've generated from one facility to another one without reinventing the wheel every time, right?
Yep.
I mean, just to conclude the thought. So Imagine Communications now have a virtualized entire broadcast production chain in the cloud. You can swipe your credit card and stand up Cartoon Network tomorrow. That exists. The ability to route video over switches over commercial off-the-shelf Cisco switches has been very well demonstrated by Tom Edwards out of Fox, and he's routing video through these things, beating the 7 bells of heck out of them without dropping a single frame over weeks and weeks of testing. Unless we as an industry adopt this stuff, to your point, we're just going to die.
Yeah, but the good news is that there is a very smart group of people who are engaged. Jack, I think this gentleman was first. And I also would just challenge the guy who said that. Could he do that without IETF standard 5? Which, by the way, is the standard for IP. Anyway, please.
So taking practical next steps moving forward, it's like a post facility doing this. We're kind of still in that proprietary stage with all these different things. Is there, instead of, standards creation, implementation, obviously that takes a long time just to get everybody on board and which one we go with and all that. I guess if you're looking at adopting those, the IP stuff now, is there certain things you should look for with those companies that would help with that interoperability in the future as you're kind of standing in between the proprietary and the interoperability? Does that make sense?
It makes perfect sense. And boy, this is something I've struggled with too. I would just say, if you can, know your vendors and understand their strategies. As I said, we've got 3 non-interoperable implementations of IP-based video now for inside facilities. And there's a time, probably back when I worked here, when I would have been railing against those vendors and roundly condemning them. And I now realize that they're just responding to the market. People want to buy stuff, and there aren't these standards. This fundamental groundwork hasn't been laid yet. Well, people want to buy the new stuff. They don't want to buy the old stuff, so they make something, right? But if you can talk to the vendors and understand what their position is, are they saying, well, we're committed over the longer term to move to this? It's a tough call, right? I faced exactly the same sort of decision when I worked here that you're talking about. And all I can tell you, some companies will give you lip service and other companies will work to help you integrate a facility. And, in your situation and my situation when I was here, you were kind of left with the cleanup on aisle 3, when at the end of the day, myself, Rick, and other people who worked here were the ones who were responsible to make things work together. So I think just that's all. I don't have an answer for you right now. We're in development. Things are moving fairly quick.
I would just say and Brad may disagree or may want to hit me when I say this, but on all the 2022 based stuff right now, as has always been the case with all new technologies. There's always a period of pain. And right now, yeah, see, oh, he gets, and I'm not going to get it. That's why he's taking it. So, and right now with all the 2022 6 and other stuff along those lines, the interoperability between vendors isn't so pretty. Yes, with a bunch of engineers standing over it, breathing on it, and rubbing it nicely, they can make it work. But we are in the pain period.
Careful.
But it was that way with SDI. It was that way with all other technologies. You know, NTSC wasn't called Never Twice the Same Color for nothing. And so eventually this stuff will all work. Eventually you'll be able to drop it together and make it work. But for some of the folks who right now are running out, we're buying this and we're building this and it's all IT and it's wonderful, good luck. We are in the pain period.
Well, and there's a good reason why it's called bleeding edge.
Yeah.
We're by the way, I want to point out we're at 9 o'clock right now, which means that this is a great topic because by 9 o'clock everybody would have been asleep if it wasn't. I can tell you that right now. But it is 9 o'clock. I want to pull to a couple last questions, and please, everyone, copy down Brad's information.
I guess this is more comment. I love that illustration you made of the 29-year-old IT guy who's got 10 years of experience, and we need to figure out a way to leverage him.
It was a girl.
Oh, you're right.
Woman.
Her, yes, right. We need to leverage her and accommodate, and I think part of that is, you know, we've been hearing for 5 years now, we got to leverage IT infrastructure, which to most of us is, okay, got to use Ethernet, IP switching, and just gravitates to that. But what you were saying is not just that. That was 5 years ago. We need to start speaking UML or understand some basics of UML. We need to get comfortable with URLs and URIs in our media space. We're start using that language as opposed to whatever we've been using. Something that struck me a couple months ago, we had a presentation here where there was a slide that mentioned DPI, and it was about web delivered video. And so DPI, ad insertion, you know, we use SCUDY 35, SCUDY 104, and there was this whole slide full of a dozen other standards that, you know, Netflix is using this, Apple's doing that. Everybody's just went off and reinvented their own technology, and it's like, oh my God, we've already done this. Why are you guys doing that? They're running off and doing their own thing. We need to come around and harness that, because there's, you know, billion-dollar industry that's running away with the ball. We need to steer them, and interoperability is part of that.
Yeah, and to that point, I think one of the things that's really worth some pretty serious thought is where we can improve interoperability. And Steve, you said the guy's just going to go download something off the website. What he's talking about is services. And so I'll take just a minute if we've got a moment to explain this. The hard part these days is not necessarily being able to interact with some other thing, SCUDY device or whatever it is. That's why there's a lot of them, because figuring out how to interface to something is actually now pretty easy. That's because these guys understand the concept of services and how you offer the ability, let's say, to do triggers over a network. And all you need is a device that's got a web page, a web server on it, and the ability to properly advertise what that does. And you take that 29-year-old programmer and you say, you've got a week, build me an interface, and she'll come back 3 days later and say it's done. So do we necessarily have to develop every interface, standards for every interface? I think my thinking on this is evolving, and maybe not, but do we need to wholly embrace the way that these guys are able to very quickly on their own figure out what a device is capable of doing, and then writing code and getting that device to do something that they want? Right now, we need to know how that's done. And there's standard methodology. There's very solid patterns for doing that. As an industry, we need smart people who know how that works, who can read a UML diagram, who know how to go and get an XSD off of a web page for a camera that they want to be able to run the iris on, and 5 minutes later be sitting there with a hacked up code page feeding you requests back through a HTTP GET or posts to do that. And that's what we got to change, those sorts of things.
You know, just real quick, a couple years ago, they came out with the Raspberry Pi, and I was all excited about it, $35, because this is getting simpler. Have you heard about the latest one that's come out? $9 computer, single board. It's supposed to kill the Raspberry or be super competition. We're coming out. I can imagine us saying where you're buying your computer by putting a quarter in the vending machine, and out it comes. So we need to get over to that technology and to adopt it. Any other questions? I want to do this fairly quickly.
I just have one other comment. Again, I want to thank the sponsors in the room and on the recording for the opportunity to be able to do a presentation like this. Thank you.
I've got to tell you, I, for one, am going back to the recording because I've got to play it a couple times so I can catch up on all the things I missed or didn't absorb the first time. For everybody else, it is our goal to have this up on YouTube. It'll probably take a couple weeks to go through SMPTE National. So we will make that available. Like many good books, I have to read them 2 or 3 times to get everything there. Brad, I want to thank Brad for this presentation. I think it's terrific.
I really appreciate the opportunity. Thank you, Jack.
And as your task force gets further along, we want to have you back. Tell
Happy
us
to do it.
Once you've solved all these questions, we want to have you back.